Right. So a question is like this. Is an inclined plane. There is a block here, block of mass m. Okay, friction is here, coefficient of friction here is mu. Okay, and we are pushing the block from here. Okay, we are pushing the block from here. Let's say the acceleration is a, or acceleration you have to find. Let's say acceleration you have to find. Find the acceleration. Find maximum and minimum acceleration for which block of mass m can be at rest, on the inclined plane. A similar question we did in laws of motion also, but that time there was no friction. Here friction is there. So with friction, how the question changed? Normally I would have asked you what is the acceleration, but what I have asked you here, find maximum and minimum. That means two values. Two values are there. So both the values you have to find. Okay, note the question. Done? Okay. See what to do now. Minimum and maximum acceleration we are talking. So how to find? Now let's talk about maximum acceleration first. We are going to find maximum acceleration. Okay, so maximum acceleration, if it is there, then what are the forces which are acting? That you will see on this block. Well, we all know in this one is mg. Here is mg sine theta. Here is mg cos theta. Here will be normal contact force. Then, because of the acceleration of inclined plane, there will be pseudo force acting on the small block. There will be pseudo force. A pseudo force in this direction. Okay. Now its components we have to see. Why components? Because this block is going to go along the plane. So we need to know what component of pseudo force is acting in that direction. So this is theta given. We know that this is theta from here. Okay. So component of pseudo force is here, ma cos theta. And another one is here, ma sin. So far, very good. Now, if suppose this is acceleration maximum, that means pseudo force value is maximum. Pseudo force value is maximum. That means this is a max. If this is maximum, that means this also will be maximum. And if this is maximum, that means this force will try to take the block upwards. Okay. For a maximum, ma cos theta will try to push or pull, whatever. Pull the block upwards because it's maximum. Okay, so in this case, what will happen? Friction will be acting in which direction? Friction will act downwards. Friction's direction will be like this. Because friction depends on in which direction it's likely to move. So friction is here. What we want to stop it. Stop it means this MA cos theta must be balanced by this mg sin theta and friction. Okay, so then here for equilibrium, we will say MA cos theta must be equal to mg sin theta plus friction. Which friction? Limiting friction, because you want to keep it at rest. So mu n. Put n value. What is n value? We'll see. N value is equal to mg cos theta plus ma sin theta, according to the free body diagram. So n value is mg cos theta plus ma sin theta. This is what we are going to keep here. Put it mg sin theta plus mu mg cos theta plus ma sin theta. Okay, that's equal to what? Ma cos theta. So here is ma cos theta. Okay, what we'll do now? Ma terms will take one side. This is ma here also, here ma also. Take it on this side. Let's make it here. So ma cos theta, which is this term. Bring this one here. What is this? Mu ma sin theta. Bring it this side. So minus mu ma sin theta equal to, now what is there on equal to? Mg sin theta plus mu mg cos theta. Put it here. Mg sin theta plus mu mg cos theta. Right. So from here take ma common. From here take mg common. See what's coming. Okay. Ma is taken common. Cos theta minus mu sin theta. From this side mg taken common. Sin theta plus mu cos theta. M and M gets cancelled. A value we got. A value is g sin theta plus mu cos theta by cos theta minus mu sin theta. Now this is A maximum. This is A max. Is this clear to you?
Yes, sir.
Okay, note that one. Now you are going to find A minimum. Okay, note it first and then start doing it for A minimum. Completed? Students, what is on the board that is completed? Have you copied?
Yes, sir.
Okay, then start doing for a minimum. Don't see on the board. I will also start doing. You also start, but don't see on the board. Once you have done, we will see the answers. Okay. You start. I'll be starting in a minute. Don't see on the board. Completed? See, I have done it. Is your answer matching with mine? See on the board. What is the difference in previous one and this one? Previous one is when pseudo force was maximum. When acceleration you give maximum to the block, pseudo force was maximum. Pseudo force was maximum means this component was bigger. So that's why this component was trying to take the block upwards. So when it was trying to take the block upwards, friction was acting down. But in this case, we said that acceleration is minimum. Minimum acceleration means minimum pseudo force. Minimum pseudo force means minimum value of ma cos theta. So if its value is minimum, then maybe mg sin theta will pull it downwards. So if it is going to pull it downwards, what will happen? Friction will act upward this time. That is only the difference. Okay, so that's what I have written. For minimum acceleration, pseudo force is also minimum. Hence, block is likely to move downwards. So friction will act upwards. So again, for equilibrium, mg sin theta should be equal to force of friction plus ma cos theta. Then what we did? In place of friction, we kept mu and value we kept ma on one side, mg on the other side, and we got a minimum. Is it clear?
Yes, sir.
Okay, note it. Completed?
1 minute, sir.
Yeah.